this video, we're going to have a look at combining index laws. These are the index laws we've learnt so far. Multiplying numbers with the same base, we add the powers. Dividing numbers with the same base, we subtract the powers. Raising a power to a power, we multiply the powers. Having a power of a product and a power of a quotient, and also remembering that any number to the power of 0 equals 1, known as the zero index. Let's have a look at combining index laws. 2 times a to the power of 3 times a to the power of 2 times b. Now we could rearrange this and write it as 2 times 3 times a to the power of 3 times a to the power of 2 times b, putting the numbers first and then listing our bases in alphabetical order. But rather than rewriting it, we can just look and pretend we're looking at the numbers first. So 2 times 3 is 6. A to the power of 3 times a to the power of 2. When we're multiplying with the same base, we add the powers. That is a to the power of 5. And we've got a b that's still being multiplied, so we put it in the final answer, being 6 a to the power of 5b. Question 2. Here we're looking at 5/10 times a to the power of 3 over a to the power of 5 times b to the power of 2 over b. Let's simplify each first. Here we have 1/2 times, rather than using the second index law, I'm going to think about cancelling 3 a's on the top and 3 on the bottom, and I'd be left with 1 over a to the power of 2. A to the power of 2 is the denominator. If we used the index law, where we multiplying numbers with the same base, we subtract the powers, we'd end up with a negative indice. We haven't learned how to deal with those yet, so we'll do it this way. And b squared over b is just b. Putting it finally together as one fraction, because it was given to us as a fraction, we have b over 2 to the power 2 times a squared. Question 3. Here we have products of powers, and we're going to multiply in. So we've given 2 times a to the power of 4 times 3 is 12, so the index 12, and b 3. Easy. Question 4. This time the number is in the brackets, so we also need to multiply the powers in. So we get 4 to the power of 2, x to the power of 2 times 2, which is 4, and y to the power of 3 times 2, which is 6. We could leave it this way, but we normally, with the coefficients on the numbers, will express them as their final number, 4 squared, which equals 16, x to the power of 4, y to the power of 6. Question 5. Remembering our index law for zero index, in that any number to the power of 0 is 1, but you need to be careful what is to the power of 0. In this case, the bracket is to the power of 0. It doesn't matter what's in the bracket, this means times 1. That is 5 times 1, which is 5. And last two are getting a little bit more complicated. Here we have 9 over 3 times x to the power of 6, because we have power of a power here, 2 times 3 is 6 over x, times, I'm going to write it as 1 over y squared. Y squared's on the denominator, so I just simply put a 1. Simplifying these each individually, 9 over 3 is 3. X to the power of 6 over x. We can use our quotient rule here, where we subtract our powers and we get x to the power of 5 times 1 over y squared. Putting it all together, we have 3x to the 5 over y squared, remembering it stays on the denominator. Now here's something different to finish on. Suppose we needed to simplify the expression and express it as a single power, but we're not in the same bases, and our index laws only work when we're working in the same base. But something should be jumping out at you here, 9 and 27. they can be written in the same base. 9 is 3 squared, and here it's to the power of x. And 27 is 3 cubed, and here it's to the power of 2x. Using our power of a power rule, 3 to the power of 2x times 3 to the power of 3 times 2x here is 6x. Now using our multiplication rule, multiplying numbers with the same base, we add the powers. That is 3 to the power of 2x plus 6x is 8x. And we simplified, expressing our final answer as a single power.